Everyone, today let's go over another medium that I just solved by myself a couple minutes ago. This one is called find right interval. It is a binary search question, and yeah, so I managed to do it and I'm pretty happy about that. So let's go over it. So the description is pretty confusing, but essentially you're given a 2D matrix of integers with length 2. Each sublist is length 2. So then what you want to do is find, okay, so the result is going to be of the same length as how many sublists are in the input, right? So 3 here, the result is of length 3, result is of length 1 because there's only one sublist. And then you want to find, they basically want you to find, so iterate over the intervals from left to right, and you want to find, you want to take the current end interval and you want to find from the starts the index of the one that is bigger than or equal to the current end. So for example here, current end, right, is 3. First index of current sublist. And then you have your starts, the 0th index of each sublist, which is 3, 2, 1. And then basically you want to find the index of whatever start value has a value that's bigger than or equal to 3. So 3 is bigger than or equal to 3. So we append 0, right? Because the 3 as the start, aka the 0th index, lies at the 0th index. And it is the smallest element that happens, well, the only element in this case, but the smallest element that is bigger than or equal to the current first index, which is going to be the end value, right? So pretty confusing, but so we have to do a couple things here. First of all, let's try to get all the starts and map them to the respective indices. So 2 as a start lies at the sublist index 1. 1 as a start lies at the sublist index 2. Here, 3 lies at the sublist index 0, right? So now what we want to do is, cool. Now that we have that mapping, this is all messed up. We don't want 3, 2, 1, right? We want to be able to run a binary search. So let's sort this and then run a binary search for each end. So we're going to take the end value and we're going to say, where does it go? If it goes out of bounds, then we're just going to append 0. If there is an element that's bigger than or equal to it, then we're going to get the key in the, we're going to get the same values key in the dictionary and append the index to it. So maps 0 for, let's say we're on this guy, we're at 4. Unfortunately, no element in the starts are less than or equal to 4, right? So then in that case, we just append -1 because what's going to happen is when you do a bisect left, it's going to end at index 3. There is no index 3. It's 0, 1, 2, right? So that's how you know it's going to be a -1. Otherwise, you just get the bisected value and then find its key in the dictionary. And then get the value is going to be the answer for that particular index in the result. So hopefully this makes sense. It's a little bit confusing, but when I code it up, hopefully it'll make more sense. So first, let's make a dictionary. So let's create a dictionary. And let's also create a sorted list because, again, we're going to want a binary search over the starts, the start values. So now let's iterate over the intervals. We're going to have to iterate over twice for I in intervals. If I of, well, we're just going to map the value. So d of I, 0, because we want the start value, is equal to I. And let's call this E because we want the value, not the index. So index value, right? So 0, then the values. And this is going to be E0 because E is the current sublist. And then 0th index is this guy, so 3. Let's confirm it by printing. Okay, so now 1, 0, cool for that example. This one, 3, 0, 2 is at 1. Yep, 1 is at 2. Cool. So now at the same time, we want to add E0 to our sorted list so that we can do a binary search as we loop over again. Okay, so now we're going to have this sorted list and we're going to go over intervals again from left to right, sublist by sublist, right? So sublist by sublist, and then now we're going to say the current end is going to be intervals I1, right? Because we want that current end, as it says here, the end is the first index of each sublist. So intervals current index number 1, the only other element. There's only 2 elements in each sublist. And now comes the tricky part, because we're going to do a bisect left inside of S, looking for a current end. And this is just going to place, for example, if we have 1, 2, 3, and let's say we're on 4, right? That's the current end. Then it's going to place it at wherever it goes in order. It's like an insort, basically. So at index 4 would go at index 3 imaginary, right? Index 3 would be placed at index 2, because you can think of it as going in front of whatever's equal to it, right? So it's like an append left for a queue. And so let's print B, and let's also print current end. So just to prove to you, okay, intervals I1 in range length intervals, right? That's the syntax. This is a matrix. Okay, cool. So now, as you can see, we have the current end value of 4, but the 3 is where it goes. There is no index 3 in this list because it's 0, 1, 2, 0 based indexing, right? So in that case, if B is bigger than or equal to length of S, then it's not valid. We can just append -1, right? Otherwise, then we can say the current value is equal to, the B is an index, right? This returns an index where it's supposed to be placed at. So index 2 for 3. And we're just going to say whatever the value we want is going to be S of B, which is going to give us 3. Let's print value. Result is going to be our output, our final output. So now, let's see all this value just to show you. So value is going to be 3 now, right? So 3's value, now you go to the dictionary and you get, that's going to be index 0, right? So D of value, because the value, so the bisect produces an index where it's supposed to be placed at, and then you have to get the index's value as a key in the dictionary, and then the key in the dictionary maps back to the original index, because I think all of the starts are unique, which it says here. And then at the end, you can just return the result after you do this O of n. So the overall time complexity is 2 times n, because we're looping through twice. So that should work, and it does. So passes all test cases. If we get rid of the print statements, hopefully that's a little more efficient. Nope, I guess not. Let's try this. Let's maybe try S length is going to be length of S. This sometimes helps. And also n equals to length of intervals, range n. Oh, wait a second. Length of intervals, that's not correct. Nope, not like that. That's a double list. Okay, what is going on? Okay. Let's go back to what we had. Length of S, because maybe S's length changes, right? Yeah, S length is not here. S length is supposed to be here because we already added it. Now we can do S length. We actually, this is before, this was on the list as empty at the beginning, right? There you go. I guess it didn't improve the time complexity, but just wanted to show you this is my own solution that I came up with, so I'm really proud of it. And thank you for watching, and stay tuned for more.